We have to find the Fourier series of a function on the interval from -1 to 1. The function is fx of x equal to x squared. Right, so first we're going to find a subscript 0. And we know that's going to be 1 over the half of this interval, which is 1. Integral from -1 to 1. The function, right, x squared dx. We know that's going to be x 1/3 x to the third, -1 to 1, which is 1/3 over 1 to the third minus -1 to the third, which is going to be equal to 1/3 1 plus 1, right, which is going to be 2 3. So a naught over 2, which is going to be 2/3 divided by 2, which is 1/3. Okay, so that's going to be something we're going to use for the formula. Now the next case is a subscript k. Now a subscript k is going to be the same thing. I'm not going to write 1 over 1. It's just going to be 1 from -1 to 1. The function multiplied by this part, right? Cosine k pi x over 1. I'm not going to write 1. I'm just going to write k pi x dx. Okay, so you're going to use integration by parts. Namely, this will be dv, this part here, and I'm not going to write it out here, but this is the dv. So what you should get, if you do this correctly, you should get 1 over 2 pi x squared sine k pi x, evaluated from -1 to 1. So now I want you, and then I want you to understand that this is going to be 0, because when you substitute in the x, sine of k pi, k will be an integer, right? Because this is what summation means. K will be an integer. Sine of any k being an integer with the pi will always be multiples of pi, right? Sine of any multiples of pi is always 0, right? So it's going to be 0, this whole thing. But we're not done yet, because integration by parts says that there's also a minus v du, right? Minus 2 k pi integral from -1 to 1 v du, right? v du is going to be 2x, right? Which is why you see the 2 in there. And then the x, and then sine k pi x. And remember, the v, right? The v du, the v was sine k pi x, and the constant there, right? So this is going to be what you should have, k pi x dx. Now using integration by parts again, you're going to make sure that this thing is dv, right? Extended to dx. That was dv, right? So what you should have, if you do this correctly, you should get positive 2 over k pi squared. And it's squared because remember, to find the v, you will need to have a k pi again multiplied there, right? That's why it's squared. It's going to be x cosine of k pi x. Notice that the x will always be reduced. Now it's to the first power from -1 to 1. And again, I want you to understand that this is going to be equal to 0. Why? Just for other reasons than the sign. For the reasons being that cosine of k pi, and the x doesn't change anything. Well, let's see. Does it change? I will evaluate it just in case to make sure. Okay, but this is continued minus v du, right? So it's going to be minus 2 over k pi squared v du, right? So from -1 to 1, the same function without the x this time, right? Because the x is even more reduced. Cosine k pi x dx. Okay, and this thing will be equal to 0. How do I know that? Because we will have a sign, and for the same reasons a sign was disregarded there with the 1 and -1, we will be able to disregard it again. So this whole thing will be 0. So we're dealing with just this part, right? I speculated it was equal to 0, but no, it's not equal to 0 because of this x here. If this x weren't here, or if it were x squared, then we could have said that this thing was 0. But this x actually plays around with the signs, because the -1, even the cosine being even, this x really changes the game, and I will show you. Right, so what we're basically having is 2a over k pi squared. We will have 1 times cosine k pi x minus the -1 changes the game inside the x there. -1 times cosine of k pi. Oh, sorry, not k pi x, k pi. I should have substituted the x with a 1. So just k pi. Right? K pi minus 1 times cosine of negative k pi. But negative k pi is the same for cosine as cosine of k pi, because cosine is even. But do you see, this -1 prevented us from having 0 here, the x here being evaluated at -1, right? Because this -1 creates a positive sign as a result, right? If not for that x, then this would be subtracted from that. But this -1 changes the game and makes everything a plus, right? Right, these two, it makes a plus. Right, so as a result, we will have what? We will have 2 over k pi squared 2 cosine of k pi, right? Which is going to be 4 over k pi squared cosine of k pi. So now this has two possibilities. It has two possibilities. It can equal -4 over k pi squared if k is odd. And how do I know that? Because if k was equal to 1, that's an odd integer, right? So k of cosine of pi as a result, right? Because 1 times pi is pi. Cosine of pi is -1. So you would have -4, right, over k pi squared. Now +4 over k pi squared can happen if k is even, right? Because if k is 0, for example, that's an even integer, right? K is even, you will have 0 there. Cosine of 0 is 1, so it's just positive thing, right? That's kept. Okay, so how do we express that? Well, we're not done yet, right? We need to find b subscript k, and b subscript k is going to be a lengthy integral again, and it's going to be 1 over 1. I'm not going to write it down. From -1 to 1, x squared sine this time, right? K pi x, because that's required in the formula here. Now you're going to use again the same way we did it here. You're going to use dv here. You're going to use this part as being dv, integration by parts, and you're going to try to solve this out by yourself for your own practice, but you should get 0 for this. Okay, so as a result, what we should have is this, right? Using the formula here, if you do this correctly, the formula should be a0 over 2 we found was 1/3, right? So let me write it down as Fourier series, like that. Fourier series, right? So 1/3 plus, from k is equal to 1 to infinity. Now we have to make sure that we find the correct sign. We satisfy the sign alternation here, right? Because the sign alternates, right? It's negative, positive, negative, positive, right? So we have to have a negative sign, -1 raised to some power. Now we have to have a negative when k is odd, right? So we can just leave it at k, because when k is equal to 1, this thing will be -1, right? When k is 0, when k is 2, because we start from 1 is the least k value. When k is 2, you will have a positive, right? Squaring the -1 is positive. So that's that takes care of the signs. Now we have 4 over k pi squared, and then remember this thing is gone, right? So we need the cosine. That's all we need, right? The cosine of k pi x. And we don't have to write over 1 because that doesn't change the angle. All right. In any case, this is your Fourier series representation. And if you want, you can make it k squared pi squared. If you want to distribute the power of 2 here to each of these terms. You can, each of these constants, you can, k squared, pi squared. Okay, so this is the correct Fourier series representation of the function x squared on the interval -1 from -1 to 1. Thank you so much for watching. See you in the next video.